Yeah, hi Al. Today topic structures and unions in C programming language. These are the topics or contents we are discussing in this video. What is structure with the syntax and how to allocate the memory in structure, and also basics of type def and where we are using this type def without using what will happen with using what will happen we are discussing. And so next, structure padding and how to avoid structure padding with example I'll explain. And also what is the difference between pragma pack and bitfields, means what is the difference, maybe slight difference between, and to avoid structure padding, just we are take examples and we will discuss. And next, what is the union with syntax, and next, what is the difference between union and structures. Also we discuss what is the use case of structures and unions. This is the main important question. Many interviewers are asking what is the use case of structures and union, when you are using structure and when you are using union. And we take some basic examples and we will discuss. Okay, these are the topics we are discussing in here. Next, first, it's a structure. It's a structure. It's a user-defined data type. We know the array can be used to represent group of data items and belong to different data types, same data type. In arrays, we are using only same data type, such as int or float or character only. But here we can use the array only one data type value we can use. But however, we can use array if you want to represent collection of data items, means is a different data type. If you want to use, means that is not possible in arrays, but we can use only single names. But in structure, inconvenient to handle group of uh, data types, logical related data items. Structures in C and user defined data types allocated to the group of element data type and when at the single name, means it's a group of elements in the single name we can do. Like for example, it's a syntax is a structure name is a type element 1, element 2, element 3. This is the basic syntax of structure. In type means here it's a what is the data type. It's a int, char, float. We can take in group of data types in single name. And here defining data structure. Here first, struct data, struct and structure, and my struct is the structure name or tag, and struct is the keyword of in a structure. And these are the some variables I am declaring: int variable 1 and char of char variable 8, uh, array, array of character 8, and float 8, float variable 3. It's like this is the memory representation of structure variable. So here is a structure, it's that contain variable 1 is the integer, and variable 2 is array of character, and variable 3 is the floating point. Access the structure members, the different variables types stored in a structure, it's called it's a members. The structure members can be accessed by using data operators. By using data operator we can access the structure members. The data operator, it's known as a structure member operator, and we can use that, we can access that variable. Here is a take some simple example. Just this is the two are the header files, and this is the structure tag or structure name. Struct student is the structure name. Okay, we are declaring some variables like data types like some name, roll number, and marks in int main. Just uh, accessing the values and by using data operator we can access the values like uh, s we have to just assign student equal to s1, and then just we have to call print the name, rule number and marks. Here its name is some Ramakrishna, and the rule number is 101. Its marks is 95.5. This is printing to the, this is the output. This is the basic example of structure. Okay, and next it's a memory allocation. How to allocate the memory structure? Each member of structure get memory separately. In structure, each member means it's a char, int and float. Each member it's allocating to the separate memory. uh, here here it's a totally, it's a structure, it's an example, char of 1 byte and int 4 bytes and float 4 byte. But here it's a total memory allocation is 1 char and 3 padding and 4 plus 4, total 12 bytes. It's a padding is added for the memory alignment. So why? Because it's a stuck our computer, it's allocating to the 4 kind of padding, 4 bytes of memory it's allocating at a time. And so this is the padding it's happened. So that's the, just we'll discussing later what is the padding and how to avoid like that. And next, this is the memory allocation of structure. And next, understand the type def in C. The type def keyword in the C used to create alias names for existing data type to improve the code readability and probability and makes complex declaration easier to handle. By using type def, it's an aliasing name of existing data type, and improve what is used means code readability if you, and portability, and makes complex declaration easier to handle and understand by using type def. This is the syntax: existing data type and new name. Here to new name, it's your choice. It's a existing data type. Okay, for example, this is the syntax. Here basic example I am given: type def unsigned int u init, create an alias u init for the unsigned int. Now we can declare the unit a instead of unsigned int a. So this is the simple way aliasing of the existing data type. Just we have to type def, we have to take unsigned int u init, then it's a just aliasing name of means instead of unsigned int we can use u int equal to 0. Just we can easily understand, and like that you can take any name, variable names, and we can aliasing names we can take. Okay, and using type def with structure. Without using type def, what will happen? With using type def, what will happen? This is the without using type def. So without using type def, just directly this is the normal operation. It's a declaring structure into main, it's a just calling to the that one, that's it. So but without using type def, here is a type def struct. Type def, it's a name itself we are calling, it's a type def struct, and I am taken student. This is the declaration like way we are declaring by using type def. Okay, so in this case, instead of struct to student, every time we are declaring instead of struct to student, just we are taking to directly student. Instead of struct to student means it just we are taking to the student and we can access. That time what will happen? To avoid to write need to write struct every time, means to avoid struct every time we avoid that. If you want in program, we have to multiple times we are using struct uh, struct struct student like that. But instead of that, just you are using only student, and we can access the variables and numbers to make code cleaner. And so by using type def, it's avoiding to write a struct every time, also make the code cleaner. This is the advantage. Okay. Next, it's a structure padding. What is structure padding? Structure padding is the extra memory added by the compiler to align structure members for the efficient memory access. So what is the structure pad? Extra memory added by the compiler align structure members for the efficient memory access. This happened because modern CPUs fetch data from memory in chunks. It's typically 4-bit or 8-bit based on CPU architecture. It's just fetch the memory. It's a 4-bit order or either 8-bit order. Why is the padding needed? Means to align the data in memory so the CPU access are faster, to prevent unaligned memory access, which may slow down the program. So this is the main important. So what will happen if you use structure padding? It's a CPU accesses are faster. If not using that case, CPU slow down the program. Okay. And next example without padding. So let's analyze the how to memory is allocated from the structure. So here character 1 and integer 4 and character 1. The size of structure is here. The size of structure is 4 4 4, total 12. Here it's a printing to the 4. Sorry, here it is a printing to the 12. But memory layout of 32-bit system, if you take in the 32-bit system, A it's a 1 byte, but padding 3 bytes. And B it's a 4 byte, it's a 4 bytes, and C is a 1 byte, padding 3 bytes. So total expected size is 6 byte, but actual size is due to padding it's a 12 bytes. Compiler added padding by the unused memory, the alignment order. Okay, this is the so here its actual size is 6 only, but sorry, expected size is 6 only, but actual size is due to padding it's 12 bytes. Okay. It's based on its added boundaries of common data types. It's a 32-bit, it's a 4 bytes word size, and 64-bit system it's a 8 bytes word size. The character is 1, and any address it's a 1 byte alignment, and short 2 must be at multiple of 2, and int is 4, float also 4, double 8, long 4, long 8, pointer also it's a 4. So this is the 32-bit system. In case it's a 64-bit system, character is 1 byte, short is 2, integer 4, float is 4, double 8, long 8, long 8, pointer also it's 8. It's a based on our system. It's a changing to the size of size. Okay. And how to remove padding? To reduce memory wastage, we can using packing. By using Pragma pack, we can avoid the memory waste. Okay, now is the size became 1 4 1, it's a 6, it's a no padding. By using Pragma pack, we can avoid the padding. It's takes more CPU cycle compared to before using Pragma preprocessor. Reduce the memory wastage. So here it's reduce the memory wastage by using Pragma pack. But if the it's a speed, it's a slow. Okay. Structure it's a bitfield. The bitfield allow us to specify the exact number of bits each member should occupy inside the structure. This optimizes the memory usage specifically in embedded system. In structure name, it's this is the syntax. The structure name, data type, it's a member, and also it's a bit size. How much bit size you are using? Here, it's like 1, 2, 3. Like by using bit fields, we can memory we can analyze so allocated the memory in a bit manner. Each bit, how many bits you are using, it's a directly taking to that particular bit. Okay, instead of using 4 bytes, for using 3 unsigned in variables, we are only use 1 byte. So like that, it's just bit field. By using bit fields, one only, we can analyze that case. It's not memory wasted. So here, but to avoid memory wastage, so in structures padding, we are using either bit field or uh, pragma pack. Okay, and next, unions. The union is similar to structure, but all members share the same memory. In structures, all all members, it's having different memories. If you take, it's a declaring int, float, char, it's a each variable, it's a having its own memory in union, sorry, structure. But in unions, not like that. It's all members sharing same memory. Only one member can store at value at a time. Only one member can be stored at a time. Okay, and define, this is the syntax of it's the same look like int, one, float. It's a like, it's a declaration of variable. It's a how to declare the variable. And this is the accessing the members. By using data operator, we can accessing the member. Modify one member effect all, it's a share the same memory. Okay, memory allocations in union. The union memory size is equal to the size of largest member. Here, it's a largest member is char, it's a 1 byte, int is 4, and float is 12. So here it's a largest member, it's a 4 bytes. So it's the same member, it's a sharing to all variables, but store at a time only one only. This is a pointer to union. If you ask syntax, just it's a union data pointer. It's a pointer address of d1, just it's like that, and you can accessing to the pointer values. Key difference between structures and unions. Okay, it's a memory. First point, it's a memory allocation. Each member get, it's a separate memory. Each member, it's a int, char, and float. Each member, it's a having separate memory allocation. But unions not like that. All members shared one memory location. It's a what is the largest element, it's a sharing to the all members. Sum of all member size with padding. This is the size of structure. Size of the union is, it's a largest member. Okay, all members can store values simultaneously, but only one member can put value at a time. It's a all members, it's a stored values, it's a simultaneously, it's a stored, but in union, only one member hold a value at a time. Use case, when we are using structure and when we are using unions, when multiple data fields need to be stored together, that case we are using to the structure. But when only one variable is active at a time, so that case we are using to the unions. So it's a multiple fields need to be stored together, that case we are using structure. When only one variable can active at a time, so that case we are using to the unions. When use structures and unions, use case. Okay, first, need to store multiple values at once, that case structures we are using, unions not using. Need to save memory, that case unions we are using, not using to structures. And student details, name, roll number, and marks, that case we are using to the structures, unions we are not using. And different data types at different times, means it's a sensor values, like you're using unions. Okay, this is the some basic example of union and structure. So this is the basic example. Okay, and next, why do we need unions? Memory optimization. Union save the memory by using shared store space. So for the multiple variables, this is the useful in embedded system and low memory devices, hardware register and protocol handling. And next, it's a difference between structures and unions. When we are using like that memory allocation, each member get paid their own memory and all members share the same memory, and sum of all member size the with the padding, that is the structure size is the size of it's a large member. That is when we need means when you need stored multiple values, that case we are using to the structure. When we need to store only one value at a time, we can using to the union. This is the example structures and memo and union memory usage. The structure size is 444. It's a with padding, it's a 12, but in union size is it's a 4 only. Structure size it's a 12 bytes. Each variable has its own space, own memory space, but union uses only 4 bytes. All variables share the same memory space. This is the difference between the main difference between the structure and union. What is the use case means, when we need to the stored multiple values at once, that case we are using structure. When we need stored only one value at a time, we can use into the unions. When to use unions means memory efficient data storage. If you need to the store one value at a time, that case we are using to the union. The union reduce the memory wastage. Okay, this is the main. So majorly interior concentrating on first one. So first, what is structure and next to what is union, and next to what is the structure padding and how to avoid structure padding, and what is the use case of structure and union. That is the this type of questions they asked. What is the difference between unions and structures? So here it's a like simple. What is the difference between unions and structure, and same use case when you are using union and structures. This is the some use cases, like different data types at a time. Different at a time means is a student means it's all data types means is a structure we are using. Different data types at different times. Different data types is a different time. In that case we are using to the unions. Okay, these are the some basic examples and it's a main important. Okay, these all the topics are covered. So each topic is a one questions, interview questions mostly. Also what is the structure, syntax asking, and what is the union and syntax asked, and definitely this is the main is the structure padding, how to avoid structure padding. uh, this is the base common question for every interview. This is the main pragma pack. By using pragma pack or bitfield, we can uh, avoid the padding. Okay, and next when we are using to the structure padding and sorry, when we are using to union and when you are using to the structure, this also it's a base. Next, okay, these are the type, how to data accessing to the members and defining structure. That's like variables and how to store in memory. How to store in memory means it's a 4, it's a 8 means you have to take into character is 8, right? That's why it's a 8, and float it's the same again, it's a 4. Next, if you take it's like that, it's a storing to the where memory. It's the basic example. This is the memory allocations with padding. Sometimes they are displaying to the some snippet and ask to the what is the size of structure, and if you using pragma pack, just you have to take directly told it's a 4 1 4, it's a 7. If not using for pragma pack means just you can tell it's a 4 4 4, it's a total 12. Okay, uh, this is the main important. and this happened because of modern CPUs. This is the why will it happen. It's a 4 bits, why only it's a you take a different one, why it's only 4, like that they asked questions. Here it's a means this is the happen because modern CPU fetch the data from memory in chunks. So typically it's a 4 or 8 bytes. It's a based on CPU architecture. Based on CPU architecture, we can using to the this is the main, definitely they asked question. After that, first it's a what is a structure padding, how to uh, avoid structure padding. After that, why only 4 why only 8 means it's a the CPU memory, it's a chunks manner based on CPU architecture. It's a 8 bit or 4 bit, it's a chunks manner only we are allocating. Why is padding is needed to align data is memory is accessing to the faster, if not it's a maybe slower down the program. This is the one. And next, this is the just a basic example how to the uh, analyze the size. So just it's a basic example is 32 bit. It's a 32 bit and also 64 bit data types, storage value stored size of data types. Okay, these are the some basics. Okay, this is the way difference between and when you are using structure and unions. Okay, okay, this is also same. Okay, yeah, thank you guys. Please like, share and comment, subscribe the channel, some more support. Thank you very much.